Hello everybody. In this lesson we will study about the areas of combinations of plane figures. So far we have calculated the areas of different figures separately. Let us now try to calculate the areas of some combinations of plane figures. We come across these types of figures in our daily life and also in the form of various interesting designs like flower beds, drain covers, window designs, designs on table covers, and some such examples. So let us try to solve problems where we have figures that are a combination of rectangles, circles, and so on. So welcome to the lesson. In our previous lessons, we have studied how to find the area of a sector. Suppose if theta is the central angle between the two radii, we find the area of the sector as theta over 360 times pi r squared, where r is the radius of the circle and theta is the angle between the radii. How do we find the area of a segment? It is finding the area of the sector, then minus it with the area of the triangle. We have learnt these things in the previous lesson. Now let us apply these formulas in the coming problems. Let us try this problem. In the figure, two circular flower beds have been shown on two sides of a square lawn ABCD of side 56 centimeters or meters. So we have a square lawn of 56 meters and we have two flower beds shown over here. If the center of each circular flower bed is the point of intersection O of the diagonals of the square lawn, find the sum of the areas of the lawn and the flower beds. In other words, find the area of the entire figure. So if you observe over here, O happens to be the center of the circle which is being formed by this, and center of the circle which is being formed by this. Now if we have to find the area of the entire figure, the approach is we will find the area of the sector AOB, then find the area of the sector DOC plus the area of the triangle AOD and area of the triangle BOC, and we add them together and we will get the area of the entire figure. In order to find the area of the sector AOB, we need to know what is OB, the radius of the circle. So let us label this as X. So let's label this as X. And since ABCD is a square, OA will also be X. And what will be the angle formed at O? The diagonals of a square are perpendicular to each other. We have learnt in our lower grades. So this happens to be 90 degrees. So triangle AOB is a right angle triangle. So can we apply the Pythagoras theorem? So x squared plus x squared is going to be equal to 56 squared, right? Because AB is 56. So 2x squared is going to be equal to 56 times 56. X squared is going to be 56 times 56 divided by 2. So x squared is going to be equal to 28 times 56. Let's keep it at that. What is the area of the square ABCD? So the area of the square ABCD is 56 times 56 meters squared. So this is the area of the square ABCD, and now we know what is OA and OB. Let us find out what is the area of the sector AOB. So we know that x squared is 28 times 56. We know that the area of the square ABCD is 56 times 56. Now let us find the area of the sector AOB. Now, what is the formula to find the area of the sector? It is theta over 360 times pi r squared. What is the angle theta over here? It's 90 degrees. So, it's going to be 90 over 360 times pi, which is 22 over 7, times r squared, the radius squared. The radius happens to be x. So, x squared, we already know it's 28 times 56. So, 28 times 56. This will be the area of the sector AOB, which will be the same as the area of the sector DOC. So, we know the area of the sectors. Now, we can find what is the area of the triangle AOB. So, what will be the area of the triangle AOB? If you observe, the area of the triangle will be 1/4 the area of the entire square, because the square is divided into 4 triangles. So, the area of one triangle AOB will be 1/4 the area of the square, and we need to find the area of AOD and BOC. So, we can now easily calculate that. So, area of the triangle AOD will be same as the area of the triangle BOC, which is nothing but 1/4 the area of the square. Area of the square is 56 times 56. Now, we can easily figure out the total area. The total area is going to be area of one sector AOB. How much is that? It's 90 over 360 times 22 over 7 times 28 times 56 plus the area of the sector DOC, which is the same thing, 90 over 360 times 22 over 7 times 28 times 56 plus the area of the triangle the triangle AOD, which is 1/4 the area of the square, which is plus 1/4 56 times 56 plus the area of the triangle BOC, which is 1/4 the area of the square again, 56 times 56. Now, it is a matter of simplification. So, when you simplify, you are going to get, you can remove 1/4 out, 28 out, and 56 as the common factor out. So, what remains? 22 over 7 plus 22 over 7 plus 2 plus 2. And when you further simplify, this is going to be 7 times, because 28 divided by 4 is 7. So, 7 times 56. You just have to do the simplification over here, and that is going to be 22 plus 22 plus 4 14 plus 14, removing the 7 is the common factor, meter squared. Simplification. So, this is going to give us 56 times 72, which is 4032 meter squared. So, this will be the total area of it. So, the main idea is find the area of the two sectors plus the area of the two triangles, add them together, simplify the numbers, and you get the answer. Let us try another problem. Let us try this. Find the area of the shaded region in the figure. where ABCD is a square of side 14 centimeters. So what is the idea of finding the area of the shaded region? We can first find the area of the entire square, then find the area of all the 4 circles, subtract the area of the square minus the area of the 4 circles, we will get the area of the shaded region. That is the idea of the problem. Let's get to work now. So what is the area of the square ABCD? The side is 14 centimeters. So area of the square is going to be 14 times 14, which is 196 centimeter square. Now what is the diameter of each circle? The diameters of 2 circles put together is going to be the same as the side of the square. So the diameter of one circle will be half the side of the square. That is going to be, so the diameter of each circle is going to half of 14, which is 7 centimeters. If the diameter is 7, the radius of each circle is going to be half of 7 over 2 centimeters. Now we can easily find the area of one circle. So area of one circle is pi r squared. We know what is r, 7 over 2, and pi is 22 over 7. So we can easily plug in the values of it, and we get 22 over 7 times 7 over 2 times 7 over 2. Simplify that and you get 77 over 2 centimeter squared. This is the area of one circle, but we have 4 circles. So the area of all the 4 circles will be times 4. So area of 4 circles is going to be 4 times 77 over 2, which is going to be 154 centimeter square. So now we know what is the area of all the 4 circles, and we also know what is the area of the entire square. So we can now easily find out the area of the shaded region. How do we do that? It is the area of the square, which is 196, minus it with 154, the area of the 4 circles. So the area of the shaded region will be the area of the square, which is 196, minus the area of the 4 circles, which is 154, subtract them and you get 42 centimeter square. So the area of the shaded region is 42 centimeter square. Pretty easy. First thing, find the area of the entire square. Then second step, find the area of each one circle, multiply it with 4, then subtract both the areas and you will get the area of the shaded region. So applying separate concepts into one single problem. That's how you solve areas of plane figures. Let's try another one. Let's try this. Find the area of the shaded region where ABCD is a square of side 10 centimeters and semicircles are drawn with each side of the square as diameter. So we have a square ABCD. The side of each square is 10 centimeters. There is a semicircle drawn. The diameter is 10 centimeters. So obviously the radius is going to be 5 centimeters. We need to find the area of the shaded region. Let us label the unshaded part as 1, 2, 3, 4. Now if we have to find the area of the shaded region, what we can do is we can find the area of the unshaded parts and then subtract it from the area of the entire square. We will get the area of the shaded parts. Okay, so let's get to work on it. Finding the area of 1 and 3. How will we do that? We will find the area of the entire square minus the area of the 2 semicircles on this side. We will get the area of the unshaded parts 1 and 3. So let's see. So let us find out the areas of 1 and 3. How do we find the areas of 1 and 3? It is the area of the square ABCD minus the area of the 2 semicircles, each of radius 5 centimeter. So, area of the square is 10 times 10 minus area of two semicircles. Since it's a semicircle, is going to be half pi r squared, and we have two semicircles. And now we simplify. So, when we simplify, we get 100 minus 3.14 times 25. Simplify that and you get the areas of the regions 1 and 3 as 21.5 centimeter square. The areas of the regions 4 and 2 will also be the same, 21.5. So, the area of 2 and 4 will also be 21.5 centimeters. Now, we can easily find the area of the shaded region, which is going to be the area of the square ABCD minus the areas of 1, 2, 3 and 4. And let's see how much is that going to be. So, the area of the square is 100 minus the area of 2 in a pair, 1 and 3 was 21.5 and 2 and 4 was also 21.5. So, the areas of 1, 2, 3 and 4 will be 2 times 21.5. Subtract them and we get 57 centimeter square. So, the area of the shaded region will be 57 centimeter square. Great going. This is how you find out the areas of plane figures, combination of plane figures. What you do is separate each figure. Either it's going to be in the form of a triangle or a semicircle or a circle or a square. Find their areas separately and then according to the problem you bring them together. Either you add them or you subtract them. So, it is as simple as that. I really appreciate your effort that you are putting in understanding these concepts. Do keep watching the videos, practice more and more problems. Remember, your results are in proportion to the efforts that you put in, and you have to put in your efforts. Do not worry about making mistakes. Mistakes is the step towards learning. You can only make mistakes only if you try. So, keep trying, and as you keep trying, the number of mistakes will reduce and eventually you will start doing it in the right way. So, do not be afraid of making mistakes. If you make mistakes, learn from your mistakes, because the biggest mistake is not learning from our mistakes. So, when you make a mistake, see where you have gone wrong and how you can fix it, and redo the problems and take more number of problems and work them, because practice makes people perfect. So, thank you for watching this video. Please subscribe and share. Thank you.